In this video, we're going to talk about the greatest common divisor and the least common multiple. The greatest common divisor of a group of numbers is the largest number that divides all the numbers in the set. Right? So here's what you want to think about is this number, the greatest common divisor, has to be a factor of all the other numbers. So even though it says great, the number is usually smaller than the numbers in the set. Relatively prime, just another definition that will be important to us in this section, a set of numbers is relatively prime if their GCD is 1. So if I give you a couple of numbers and they don't have anything in common, like when you look at them and you say there's nothing that they have in common, we say they're relatively prime. Easy example would be like 5 and 7. There's nothing that goes into 5, nothing that goes into 7 except 1. 5 and 7 are prime though, so sometimes people go, oh, that only happens for prime numbers. Let's think of two numbers that aren't prime, maybe like 4 and 15. 4 is not prime, 15 is not prime, but when you look at 4 and 15 together, they have nothing in common. So we call those relatively prime because they have nothing in common. So there are multiple ways to find the GCD. I'll show you two, and I really have one that's my go-to way to do it. So first, let's talk about prime factorization method. In the prime factorization method, you prime factor the numbers. So it's kind of exactly what it says it is. And then the GCD will be the product of the common factors. When you're doing this, you're going to use the highest power common to all numbers when finding the product. So let's take a look at what does that look like. So say I had 30 and 42. So you can see here I have prime factored these numbers. So for 30, I broke it into 2 times 3 times 5. And 42 is 2 times 3 times 7. So what I see here is both of the numbers have a factor of 2. Both of the numbers have a factor of 3. So I only use the things they have in common, which are 2 and 3. So the GCD of 30 and 42 is 6. Let's try it again. This time I switch the numbers. Now I have 36 and 132. Again, my first step is to find the prime factorization of each number. So 36 broke down to 2 times 2 times 3 times 3. And 132 is 2 times 2 times 3 times 11. Okay. Now we want to look for what do they have in common. Well, I can see they both have 2's, and they have 2 each, and they both have a 3. So when I look for the GCD, it's going to be 2 times 2 times 3 times, oops, that's it, 2 times 2 times 3, which is 12. All right, so why don't we have you try one? This time let's look at the GCD of 240 and 750. Go ahead and pause the video and try doing the prime factorization and look for the common factors to get the GCD, and then after you find it, come back and push play again and see how you did. All right, so here's what I got. 240 is 2 times 2 times 2 times 2 times 3 times 5. 750 is 2 times 3 times 5 times 5 times 5. Okay, so I'm looking for what do they have in common. They each have 1, 2, they each have 1, 3, they each have 1, 5. So any of those repetitions of the 2's and the 5's doesn't matter. They have to be in common. So one pair of 2's, one pair of 3's, one pair of 5's says the GCD is 30. Okay. So one more time, let's give it a try. This one's 98 and 117. I want you to try it, so pause me right now, then come back and check your answer. All right, so here's what I got. 98 is 2 times 7 times 7. 117 is 3 times 3 times 13. Now notice there's nothing in common, right? I see 2's and 7's, I see 3's and 13. So this says those are relatively prime, so the GCD is 1. I just want to point out there is always an answer. So even when you look at it and you go, there's nothing, it means the answer is 1. The answer will never be 0. It could be 1, but it can't be 0. All right. Another way to do it, and this is probably my go-to way, is called repeated division. And it kind of sets up similarly to prime factorization, except that you don't have to use primes, and you could do the division for both numbers at one time. So as I'm doing this, I'm going to divide by common factors. Don't have to be prime factors, just common factors, until I get to two numbers that have nothing in common, which we said is called relatively prime, and the GCD will be the product of the common factors. So let's take a look at that. Let's say I gave you 450 and 1,000. So the first thing I see is this 0 on the end. Tells me that I could divide by 10, and notice 10 wasn't prime, but awesome, I get to use it, so I'm getting there faster. So 10 went into 450, I got 45. 10 went into 1,000, I got 100. Now 45 and 100 are both divisible by 5, so 5 goes into 45 9 times, and 5 goes into 120 times. When I hit 9 and 20, I'm done. So the GCD is just going to be the product of these numbers I divided by. So I divided by 10 and by 5, so I'm going to multiply those together to get 50. So I want to do this again for you so you can see how this goes. So here I want to look at 114 and 600. So 114 and 600 are both even, so I know 2 is going to go into them. I can also see 1 plus 1 plus 4 is 6, and 6, 0, and 0 is 6, which tells me 3 goes into both of them. So I just divided by 6. Now you could have divided by 2 and then by 3, and you're going to get the same answer. I just went ahead and jumped to 6. So 6 went into 114 19 times. 6 goes into 600 100 times. 19 and 100 have nothing in common, so I'm finished. 6 is my GCD. All right, so here we go another time. Just the more times you see it, the better. So I have 1,250 and I have 4,500. Again, those zeros on the end say, let's go ahead and jump and divide by 10. Gives me 125 and 450. Let's divide by 5. We get 25 and 90. So let's divide by 5 again. I get 5 and 18. So I stop. I look at what did I divide by? I divided by 10, 5, and 5. So I want to multiply 10, 5, and 5, and it shows me the GCD is 250. Okay, so let's do another concept, and this one's called least common multiple. So the least common multiple, or LCM for short, of a group of numbers is the smallest number that is a multiple of all the numbers in the set. Okay, let's go back and say again, greatest common divisor says greatest, and we always got a number that was kind of smaller than the numbers in the set. Least common multiple, even though it says least, our answer is going to be bigger than the numbers in the set. So they do have this backwards kind of feel that least is big and greater is small, which is kind of unusual, but you'll get used to it. Okay. Once again, you have both ways you can do it. You could do prime factorization, so you can prime factor all the numbers, and then the LCM is going to be the product of all the factors. Do you notice I say all this time? And then to the highest exponent that they appear in any of the numbers in the set. Repeated division, again, I'm going to divide until the quotients are relatively prime, and then the LCM is going to be the product of the divisors and the relatively prime quotients. So this method works for 2 numbers in this repeated division. So if you have more than that, you really would have to use the prime factorization method. So I did want to point that out on the repeated division. Only use it for 2 numbers. Prime factorization wouldn't matter how many numbers I have. All right, so let's start with prime factorization. I have 54 and 24. So I broke 54 into 2 times 3 times 3 times 3. 24 into 2 times 2 times 2 times 3. Now look, I have 2 and I have 2 cubed. So I'm going to have to use 2 cubed. I have 3 and I have 3 cubed. I'm going to have to use 3 cubed. So when I'm using the powers, I have to use the highest that it appears. So 2 cubed times 3 cubed is 216. Let's look at repeated division, just so we can jump there because I really do prefer this method. So here I have 54 and 24, and the first thing I see is, well, 2 would go into both. So 2 goes into 54, 27, 2 goes into 24, 12. 3 goes into 27 9 times, 3 goes into 12 4 times. So now that I'm done, 9 and 4 have nothing in common. Now I just take all of the numbers, so the things I factored and the quotients I got. What I think is that LCM, doesn't this kind of look like an L the way I circle it? And I circle it like that on purpose to make it look like an L. So think. Just go straight down when I do GCD, and I make an L when I do LCM. Maybe that'll help you differentiate between the two. So 2, 3, 9, and 4 gave me 216. All right, so this one, let's do the prime factorization method for 300 and 280 to find the LCM. Once again, you can see I went ahead and did that breakdown. 2, 2, 3, 5, 5. Right, so there's my prime factorization. Then 2, 2, 2, 5, 7. So I'm looking, I see 2 2s and I see 3 2s, so I got to use the 3 of them. Here's 1 3, throw that in. I have 2 5s, I have 1 5, let's throw in the 2, and then I have a 7. So everything that appears to its highest power goes in the LCM. Multiply that together, I get 4,200. Let's try another one with repeated division. So this one's 300 and 280. And this is not the first time we've had this with a 0 at the end where we say go ahead, jump, and divide by 10. So 10 goes into 300. I get 30 times. 10 into 280 is 28. Those numbers are even, so I'm going to divide by 2 and get 15 and 14. Okay. At this point, 15 and 14 are relatively prime, so now I just want to multiply those outside kind of L-shaped numbers. So 10, 2, 15, and 14 gives me 4,200. All right, so why don't you try this one, which means pause me. Try 40 and 81 and see what you get, and try using prime factorization. All right, so here's what I see. 40 is 2 times 2 times 2 times 5. 81 is 3 times 3 times 3 times 3. So when I'm looking at it, they don't have anything in common. That's no big deal. I'm going to take all my 2's, which is 2 cubes. I'm going to take all my 3's, which is 3 to the 4th, and I have 1 5. I'm going to put all of those together, and I get 3,240. All right, so here's one more for you to try. This is our last one. Try to find the LCM of 1,400 and 4,900, and go ahead and try repeated division. That way we've tried both of them. Okay. So here's what I have. 2 zeros this time. So instead of dividing by 10, let's go ahead and jump to divide by 100, which gives me 14 and 49. I know 7 goes into both of those, so that gives me 2 and 7. So I'm multiplying these outside numbers, 100, 7, 2, and 7, which gives me 90.